What is ka-Mathverse? Welcome back! This is Cedie and welcome to Cedie's Mathverse. So for today's video, I will be discussing fundamental geometry formulae. Here, in this video, we will recall some of the most commonly used geometry formulas, such as the Gougu Theorem, the interior and exterior angles, and the number of diagonals of a polygon. Without further ado, let's get started. So the first basic geometry principle that we will discuss is the Gougu Theorem. Although its name may not seem familiar to most of you, the concept is well known to a lot of people. Consider a right triangle with legs A and B, and its longest side being C. The longest side of a right triangle is called the hypotenuse. From here, we can deduce a relationship between the side lengths of this right triangle. It is well known that the square of the side length C is equivalent to the sum of the squares of the side lengths A and B. Yes, Gougu Theorem is also called the Pythagorean Theorem. So, how can we use the Gougu Theorem or the Pythagorean Theorem? We can use it on problems like this. Consider a right triangle whose legs are 4 units and 33 units in length. What is the length of the hypotenuse M? So from the Gougu Theorem, we know that the sum of the squares of 4 and 33, so we have 4 squared plus square root of 33 squared, is equivalent to the square of M, which is the hypotenuse, M squared. 4 squared is 16, and the square of square root of 33 is 33. Then, M squared. 16 plus 33 equals 49. 49 equals M squared, and the square root of 49 is equal to M, which in turn gives us M equals 7. So the length of the hypotenuse M is 7 units. Here is another example problem. As we can see, we have here a quadrilateral with side lengths 5, R, 10, and 12. It is known that there are 2 right triangles in this quadrilateral. One with legs 5 and 12, and the other right triangle has legs R and 10. We need to solve for the value of R. So how can we solve this problem? First, we must note that they have the same hypotenuse, or the longest side. So we must solve the hypotenuse first. Let H be the hypotenuse of this triangle. So we have the relationship 5 squared plus 12 squared equals H squared. Then, 5 squared is 5 times 5, which is 25. 12 squared is 12 times 12, 144, equals h squared. This gives us h squared equals 169, or h equals 13 units. Now that we know the value of h, we can use this measurement to solve for r. We have the relationship 10 squared plus r squared equals 13 squared. Then, 10 squared is 10 times 10, which is 100. We have r squared. This is the one we need. 13 squared is 13 times 13, 169. Then, we transpose 100, so we have r squared equals 169 minus 100 is equals to 69. Then, we solve for r. We have r equals square root of 69. And since you cannot simplify square root of 69 further, we have the final answer, r is equal to square root of 69. Now, the second geometry principle that we will tackle is the concept of interior and exterior angles of polygons. So, how can we calculate the sum of the interior angles of a polygon with n sides? Given a polygon with n sides, the formula for the sum of interior angles is 180 multiplied by the quantity n minus 2 degrees. The sum of its exterior angles, however, is a constant, 360 degrees. No matter what value of n you use, the sum of the exterior angles of a polygon will always be equivalent to 360 degrees. So here is an example problem for the interior and exterior angles. What is the sum of the interior angles of a nonagon? Okay, we know that a nonagon is a polygon with 9 sides. Then, we can use the formula 180 multiplied by quantity n minus 2 degrees. We just substitute n equals 9. So we have 180 multiplied by 9 minus 2 degrees is equal to 180 times 7 degrees is equal to 1,260 degrees. That is the sum of the nonagon's interior angles. We have another example problem, and this time, we're looking for the number of sides instead of the sum of the interior angles. So the problem goes as follows. The sum of the interior angles of a polygon is 1,440 degrees. How many sides does it have? So, we know that the formula for the sum of interior angles is 180 multiplied by quantity n minus 2 degrees. We just equate it to 1,440 degrees. So we have n minus 2 equals 1,440 over 180. N minus 2 equals 8. And then we can solve for n. N is basically 8 plus 2 equals 10. Now, we have special cases for regular polygons. If your given polygon is a regular polygon, which means it has equal sides and equal angles, you can solve for each interior or exterior angle it has. For the interior angle, the formula is 180 multiplied by the quantity n minus 2 all over n degrees. Meanwhile, the formula for the exterior angle is simply 360 over n degrees. So how can we apply these two formula? Let's have examples. So here is an example problem. If a regular polygon has 20 sides, what is the measure of each? Letter A, interior angle. B, exterior angle. So for the interior angle, we just have to substitute the value of n, which is 20. We have 180 multiplied by 20 minus 2 all over 20. Then, we evaluate. We have 180 divided by 20 is 9. 20 minus 2 is 18, which gives us 162 degrees. So, the correct answer for A is 162 degrees. Meanwhile, for the exterior angle, we just have to divide 20 to 360. We have 360 over 20 equals 18 degrees. Here is another example problem. The exterior angles of a regular polygon measure 24 degrees each. How many sides does it have? We know that the formula for the measure of exterior angle is 360 over n degrees. We just equate this formula to 24 so we can solve for n, which is the number of sides. We have n equals 360 over 24. Or simply, n. Then, all we have to do is to equate 160 degrees into the formula. So we have 180 times quantity n minus 2 divided by n equals 160. We multiply both sides by n. So we have 180 multiplied by quantity n minus 2 equals 160n. Then, we distribute 180 to n and to negative 2. So we have 180n minus 360 equals 160n. We isolate all terms with n and the constant 360. We have 180n minus 160n equals 360. Then, we perform operations. We have 20n equals 360, which gives us n equals 18. Now, the last geometry topic that we will discuss is the number of diagonals of a polygon. So the total number of diagonals of any polygon is n multiplied by quantity n minus 3 divided by 2. However, if you want to find the distinct lengths of diagonals a polygon has, it means that the diagonals must be of a different length. We have the floor of quantity n over 2 minus 1. So for those people who do not know how the floor function works, the floor function is the largest integer less than or equal to a certain number. For example, the floor of 4.2 is 4. Since 4 is less than 4.2 and it is an integer, and it is the largest possible integer. The floor of 2 is 2, since 2 is an integer. That is how the floor function works. Now, let us have example problems. First example problem. How many diagonals does a 10-sided polygon have? Recall from earlier that the formula for the number of diagonals is n multiplied by quantity n minus 3 over 2. We just have to plug n equals 10. So we have 10 multiplied by 10 minus 3 over 2. Then we get 10 over 2 is 5. Then 10 minus 3 is 7. We have 35 diagonals. So here is another example problem. How many distinct lengths of diagonals does a regular 14gon have? We know that the formula is simply the floor of quantity n minus 2 minus 1. Thus, we just substitute the 14 into the formula, so we get floor of 14 over 2 minus 1, which in turn gives us 7 minus 1 equals 6. So there are 6 distinct lengths. So here is another example problem. But this time, we are looking for the number of sides. Here is the problem. The total number of diagonals of a polygon with n sides is 54. What is n? All we have to do is to equate 54 into the formula for the total number of diagonals. We have n multiplied by quantity n minus 3 over 2 equals 54. We multiply both sides of the equation by 2. So we have n multiplied by quantity n minus 3 equals 54 times 2, 108. We distribute n to the terms n and negative 3. So we get n times n squared. Negative 3 times n, negative 3n. Equals 108. Then we move the constant to form a quadratic equation. N squared minus 3n minus 108 equals 0. By factoring or quadratic formula, we can get n equals 12 or negative 9. Remember that a polygon cannot have a negative number of sides. So we discard n equals negative 9 and we have n equals 12. So the polygon has 12 sides. So that is all for today's video, ka-Mathverse. I hope you enjoyed this video, and if you did, please leave a thumbs up as well as subscribe to Cedie's Mathverse. If you want to suggest some topics or improvements, kindly leave them in the comment section below. See you guys next time, and always remember, mathematics is incomplete without you.